Okay, with this question, it says that a ideal gas is in a cylinder of an engine and it's compressed from 400 milliliters to 50 milliliters during a compression stroke against a constant pressure of 8 atmospheres. At the same time, 140 joules of energy is transferred from the gas to the surroundings as heat. What is the total change in the internal energy of the gas in joules? Okay, so we got to be able to envision this. So we've got a cylinder here. That is a really poorly drawn cylinder. Wow, I can do better than that. Let me try that again. So I've got a cylinder here, and inside the cylinder we've got a piston. And this piston is pushing down, and the gas that's inside of it is getting compressed. So in between these two cylinders, we're pushing down on it. These two rings inside the cylinder, we're pushing down. The gas is getting compressed, and the pressure is going up. As that pressure goes up, when you pressurize a gas, it gives off heat. So heat is coming out of that. And it says here in the process that 140 joules of energy comes out. 140 joules of energy comes out of this reaction. That should be a J. Looks like a 5. 140 joules of energy. It's coming out of that out of that process. The cylinder gets compressed down. So here it is. Here's step 1. And then it gets compressed down at step 2. So now it has a volume of 50. If I write the word right, it works better. Wow. I'm going to get better at this, I hope. 50 milliliters, where we started out at 400 milliliters. Okay, there's a little equation where you can figure that out. And that equation is the work that's done on the system. The work would be in joules. That would be energy. Is equal to negative pressure times the change in volume. Okay. Now the pressure in this case was 8 atmospheres. That's a unit of pressure here. So the work is equal to negative 8.00 atmospheres times the change in the volume. Well, the change in the volume goes from 400 to 50. So it would be 400 minus 50 milliliters, which would give us a total change of negative 350. I did that backwards. See, I'm going to give you the negative number. The total change is going to be the final minus the initial. And these are all in milliliters, so that would be negative 350 milliliters. But that doesn't work because we always have to have it in liters, so that's 0.350 liters, and it's negative because the change was a negative number. So here we put negative 0.350 liters. And when we do the math on that, I'm going to do my math real quick. We get 8 times 0.350. We get 2.8 because we got a negative here and we got a negative here, so they cancel out. So we get 2.8 liters times atmospheres. And that's the amount of work that's done. But you see, that's not our right units because we're not working with liters atmospheres. We need to be looking at joules so we can compare the energies. But there is a conversion factor that goes from liters atmospheres to joules, and that is that the liters atmospheres times 101.3 joules over liters atmospheres will give us the energy in joules. So as I do that calculation, I get 2.8 times 101.3. I get 283.6. We only had 3 significant figures when we were back up here, remember? So this would actually only be 284 joules of energy. Now we got joules of energy here and we got joules of energy here, and we want to look at what the total change is. Well, the change in the energy here is equal to Q. That's not a Q. Q plus W. Q is heat and W is work. So Q plus W. So the amount of heat that was given off is 140 joules. Now that is negative. The reason that is negative is because the heat left the system. And then we're going to add that to the amount of work that was done, and we calculated here that by the change in volume against the constant pressure, that the amount of work that was done was, oh, where's my math? 284 joules. And so we just subtract those numbers, and we'll get the total on the system is 144 joules. That's going to be the total change. That is the total change in the internal energy of the gas. So that's the delta U for that gas. 144 joules. So did the gas get hotter? Did it take in heat, or did it lose heat? Well, we see that's a positive value. So since it's a positive value, that means that heat went into the system.